Hi, everyone. Happy Monday. So hopefully you watched the intro video. If not, you really need to go watch that because there's a lot of information in there. It'll let you know what is expected of you today and what the rest of the week is going to look like. So if you didn't go and watch the intro video, I really need you to do so because it's super important. Okay, so we're going to get right into projectile motion word problems today. So a projectile, I know this is so gross, right? But I always think when I hear the word projectile as a mom, I think of projectile vomit. So I know that's super disgusting, but it's almost like something that is thrown or dropped or kicked, and it creates that parabola, like path, right? So it's like the path that the object takes. So I always think like besides math class, when we're doing projectile motion, I rarely hear the word projectile in the real world in like my normal life, except for like projectile vomit. So that's the only thing I can think of, and I'm really sorry. So if you play sports, think of like the projectile of the object being like the ball that you kick or that you hit or that you throw. So those are projectiles, and we can use quadratic functions to help us figure out a couple of things. We can figure out, let's say I am kicking a soccer ball, and I want to know how long it's going to take. Once I kick the ball, I want to know how long it's going to take for the ball to come back and land on the ground. I can use a quadratic equation to help me figure that out. Or if I want to know if I am hiking and I have a grapple, which is that thing that you throw that helps you climb the mountain. I'm sorry, you guys know that my words escape me all the time. I think it's old age and I don't get much sleep these days. Anyway, I'm really sorry, but it's like when you're, I don't know if any of you climb mountains or any of that stuff, but when you're like scaling a wall or a mountain, you can use a grapple. And so you throw that up and then it like hooks on, and then you use it to help you climb the mountain without you falling, because if you fall, it's supporting you and holding you. Usually it's around your waist. So anyway, you can figure out how high you need to throw the grapple in order to clear whatever it is, like the ledge. So you can figure out the force, you can figure out the timing, you can figure out your max height, like all of that stuff. So it's really useful. Like I said, it's not in your like normal everyday life where you need to figure out the timing or max height. But it is useful if you are planning these events or you're trying to figure stuff out, like the timing or max height, or at how many seconds, what is the height? You can figure all of that out by using a quadratic. So I feel like I'm rambling. I'm really sorry. I'm going to try to keep this video short. You know, that's not going to work. So we updated our table of contents last week. So what I need you to do, please, is turn to your page 86. So projectile motion word problems. And before we get into any of the actual notes, we're going to identify some of the key features of your parabola. Okay, so leave a couple of lines, and then what I would like you to draw is the first quadrant of a coordinate plane. Okay, oh, sorry. So let's draw that first quadrant of the coordinate plane. So a projectile, like I said, is an object that is dropped or launched or thrown, and it moves along that curved path under the action of velocity, which is speed and direction. So a projectile word problem. All right, so sorry, this. All right, so in a projectile problem, the object reaches a maximum height So the keywords here are maximum height. So what we've been using for maximum and minimums, hopefully you were like, oh, okay. This is your vertex of the parabola, right? So if you have your coordinate plane here, and this is your x-axis, right? And we are usually looking at time, and you have to be aware of if it's talking about seconds. Typically with projectile motion, you're dealing with seconds, but it could be minutes, it could be hours. But if you're thinking about something being thrown or kicked or launched, it's usually seconds. So your time, which is your x coordinate, right? That's going to give you the time that this object takes. So let's use the soccer ball, right? So you're going to start at 0 seconds, and on this axis over here, you would have your height. And again, the label for that varies. So sometimes it's feet, meters, whatever it is. So you need to read your problem there. So if you're kicking something, right, like a soccer ball, or you're teeing off for golf and you're going to hit your golf ball, right, you're going to start at 0 seconds and 0 feet, let's say. Okay, so that's your origin. That's where you start, right? And then your object kind of takes this curved path like this. Okay, and let me just extend that axis here. Okay, so this is the amount of time once I kicked the ball. This is the amount of time that passes until it reaches the ground again. Okay, so here's your parabola. Here's your quadratic function. So your maximum height, right, if that's the middle, here is your max height. Now, your maximum height, if it says how high, that's going to be your y coordinate of your vertex. Okay, so your y coordinate. You can also say how long it's going to take for your object to reach the max height. So if it says how long until your soccer ball reaches its max height, you're going to be looking for the time. Okay, so max height is going to be your y value of your vertex, and the time it takes is your x value of your vertex. So remember, in order to find the time it takes for you to reach your maximum height, it's negative b over 2a for your x coordinate. And then you have to substitute that value into your quadratic function to find the y coordinate. Okay? So that's an example of if you were to kick something. So let's say you are standing on a ladder. Okay, so if you're standing on a ladder and you need to throw something up onto the roof of a house. So you're on a ladder and you need to get something off the roof or whatever. You might not always be starting at height 0, is my point. So if you have a starting height and then you throw something, right? Okay. So now here is your starting height. Okay. So now your parabola looks something like this. And so if you want to know, or let's say you're on a ladder and you have to throw something down to the person on the ground, right? So you throw it, your object takes this path here. So when it lands, that's the amount of time that it took, right? So when you're solving for time, right? So this here and this here, when you're looking to see when the object hits the ground, you're solving your quadratic. So let's say when the object hits the ground, the y coordinate, the height, is 0. So you're looking for your roots. So you're solving the quadratic to see when it crosses that x-axis. Okay, so this is important. So you need to know what you need to do to answer the question. This is why projectiles at first can seem a little bit confusing, but then as you go through it, it makes more sense. Okay, so max height, if they're asking for the actual height, you would use your negative b over 2a for your x coordinate, and then you need to substitute that in for the y, because remember, this negative b over 2a is going to tell you the time it took for the object to reach the maximum height. Then when you substitute that time in, say it's 5 seconds, if you substitute 5 into your quadratic formula and you solve it or you simplify it, that's going to give you the actual max height. So I'm going to take you through just a couple of more things that you need to know, and then we'll do some examples. Okay, so let's talk about the quadratic equation for projectile motion. So your quadratic equations. sometimes they're called vertical motion. So projectile or vertical. So what those equations look like is H is equal to, and remember, H is like saying Y equals, right? So this is your height. So your height equals negative 16 t squared plus your velocity, so V times T, plus S. So I'm going to take you through this. Your T, the T represents time. Okay? So this is like ax squared plus bx plus c. So the negative 16 is taking into account your gravity. So this takes into account gravity. Okay, so for most of your, I don't want to say all, because I know there's probably one or two out there that doesn't start with negative 16 t squared. But for the majority of the word problems with projectile motion, your A value, or this number right here for gravity, is going to be your negative 16. So this would be your A value. Okay. V is velocity. And remember, velocity is your speed and direction, right? So velocity, they'll usually give you that as well. And this is usually in feet per second. And that's your B value. And then your S, this is your initial height. Because if you remember, and this is your C value, if you remember back to when we did ax squared plus bx plus c, that C value was your y-intercept, right? So up here, your y-intercept, that's your starting height, okay? That's where your graph crosses your y-axis. Okay, so now that we have all of that, you can use the vertical motion model to determine how long it takes for an object to reach different stages of height. So we can use this negative 16t squared plus vt plus s. We can use that to help us figure out different parts of the quadratic. So let's look at an example. So I'm going to turn the page so I have enough room and I don't have to flip back and forth. So we're going to look at an example. So example 1. So now we're going to put it all together. Okay, so a soccer ball. I'm not going to write the whole thing. I'm just going to write keywords. So a soccer ball is kicked from the ground. With an initial upward velocity of 90 feet per second. The equation H equals negative 16 t squared plus 90t gives the height h of the ball after t seconds. So we want to know, what is the maximum height of the ball? So we have a soccer ball that is kicked from the ground. So the soccer ball being kicked from the ground, that's going to tell me that my S value, or my starting height, is 0. And it has a velocity of 90 feet per second. So then they give you your quadratic equation. So this is given to you, right? But now you know why it looks this way. So the -16, that takes into account gravity, because everything has gravity. Everything is being pulled towards the earth. So we have to account for gravity. And then it tells you the velocity at which the soccer ball is kicked. So we want to find the maximum height of the ball. So if I think about it, it goes back to this quadratic over here that we talked about on the front, this orange parabola, and I want my maximum height. So if I want max height, I am looking for my y coordinate from my vertex of my quadratic. Okay, so I have h is equal to, I just need to look at my colors really quick, -16 t squared plus 90t. So if I'm looking for my maximum height, I want my y coordinate of the vertex. And how do I find that? I have to find the time it took my soccer ball to reach the max height, and then find that y coordinate for the height. So just to show you, right? So your ball is kicked from the ground, so it looks like this, the parabola, and here is your max height. So in order to find the max height here, I need to find the time first and then find that y value for your max height, since this is height and this is time. Hopefully that makes sense. Okay? So I know that my A value is -16 and my B value is 90. And so I know that -b over 2a, so make sure you have your calculators, is going to give me my x coordinate. So x is going to be equal to -90, b over 2 times -16, and -16 times 2 is -32. So -90 divided by -32 is 2.8125. And we do not want to round. So 2.8125. So make yourself a note. Don't round until the end. So what we just found out is that after 2.8125 seconds, the ball reaches its max height. So now I need to find my maximum height, and this is why we don't round until the end. So h is equal to -16 times 2.8125 quantity squared, plus 90 times 2.8125. So make sure that you follow your order of operations. So 2.8125 squared times negative 16. Oops. Okay. Plus, I'm going to do parentheses, 90 times 2.8125, and I get 126.5625. So I did all of that out. It is important how you put it in your calculator. All right, so I have 126.5625, and now I can round. So let's round to the nearest tenth. So my maximum height was, so the max height of the ball is 126.6 feet. So the ball went 126.6 feet in the air. That was its highest point. Okay? So let me show you why it's important that we don't round until the end. So let's say I did 2.8, right? So I have 2.8 squared times negative 16 plus 90 times 2.8. I mean, okay, this was a bad example because you got the same answer. But I'll show you in other problems why. So it will throw it off by like a tenth or two, and sometimes a little bit more. So that's why we don't want to do that. Okay, so part A asked for the maximum height of the ball. So we went through our math and we found the maximum height. So now part B wants to know how many seconds will it take for the ball to reach the ground. So I want to know how many seconds it's going to take for my ball to reach the ground. So this is asking me to solve my quadratic. I need my roots. So I need to find the roots. So solve it. And we all know at this point that I love my quadratic formula, and I think you can agree that the quadratic formula is probably going to give us it's probably the easiest method. So I want x is equal to negative b, so negative 90, plus or minus the square root of b squared, so 90 squared, minus 4 times a, which is negative 16, times c, which is 0. My c is 0. So, and that's all over 2 times a. So 2 times negative 16. So since this 4 times negative 16 times 0 is going to cancel this whole thing out, right? So it's negative 90 plus or minus the square root of 90 squared over 2 times negative 16, which is negative 32. So 90 squared, and then I'm taking the square root of that. So hopefully you realize that if I do 90 squared and take the square root, I'm going to get 90, right? Because squares and square roots are going to undo each other. So what I'm left with is x is equal to negative 90 plus or minus 90 divided by negative 32. Okay, so now we have our two solutions. So negative 90 plus 90 divided by 32, and then negative 90 minus 90 divided by negative 32. Negative 90 plus 90 is going to give me 0. And that makes sense because remember, it started at the ground. So my initial height was 0. So one of my roots should be 0. And then I have negative 90 minus 90. So negative 180 divided by negative 32. And I get 5.625. So let's say about 5.6. So this means I'm going to choose this root to answer my question, because you should get two roots, but 0 is its starting point. So that's not the root I want, right? So it takes the ball about 5.6 seconds to reach the ground. Okay, so hopefully that made sense. All right, let's look at one more example. Okay. So example 2. So Eva is jumping on a trampoline. Her height h at time t can be modeled by the equation h equals negative 16 t squared plus 20t plus 6. Would Eva reach a height of 14 feet? Okay, and then explain. So we have our quadratic equation, h equals negative 16t squared plus 20t plus 6. So this means that the trampoline is 6 feet off the ground. So that's her starting height. And we want to know, is she ever going to reach a height of 14 feet? So what they're asking for is, what we need to find out is the max height that she will get from this trampoline. So if I'm looking for my max height, I have h is equal to negative 16t squared plus 20t plus 6. So that means A is negative 16, B is 20, and C is 6. So I want to find my max height. So in order to do that, I have to do negative b over 2a. So x is equal to negative b over 2 times a, which is negative 16. So I have negative 20 over negative 32. And so what I'm going to get, so negative 20 divided by negative 32 is 0.6 0.625. So that's when she reached her max height, right? This is the time, 0.625. This is the time it took for her to reach her max height. Okay, so it took her over a half of a second. So it took her 0.625 seconds to get to her max height. So in order to find her max height, I have to substitute this in for t. So h is equal to -16 times 0.625 squared plus 20 times 0.625 plus 6. So I'm going to square 0.625 first. Okay, I don't want that fraction. Times -16. Oh, I have to change my mode here. So -16 times 0.625 squared okay. Then I'm going to add 20 times 0.625. And then I'm going to add 6. So after I did that math, I get that her height, her maximum height is 12.25 feet. So would Eva reach a height of 14 feet? Our answer is no. Eva, and I don't start with no, Eva would not reach a height of 14 feet. Okay, so I answered the question. Eva would not reach a height of 14 feet. So now I'm explaining why. So using the quadratic formula, and solving for x, for the x value of the vertex, Eva's max height was reached after 0.625 seconds. This means her maximum height is only 12.25 feet, meaning she is 1.75 feet lower than 14 feet. So something along those lines. Okay, we don't have to go into all the math because if we needed to prove it, we could put our math down here, but that's not what we're focusing on today. If we were in school, we would be focusing on that, but we're not. So you got lucky. All right. So that's how you can use quadratics to find your maximum height, the time it takes to reach your maximum height, the time it takes to reach the ground. If it said like after how many seconds, or what is the height after 3 seconds, you could substitute 3 in for your t and then figure out your maximum height. So there is a second video that goes over the practice problems. Now, I can tell those of you that took the time to watch the practice problems if you needed to, or you didn't have to because you got the concept after the first video, because you did well on your edge elastic from last class. If you didn't, I spend a lot of time doing a video showing you how to solve practice problems that your assignment takes after. So please watch it. If you need help, please practice your practice problems, because when you do the assessment portion, I'm not going to be able to help you because it's an assessment. So the time to ask me for help is before you do it. So do the practice problems. Your assessment, as I said, has also consecutive integers and area. So if you didn't really get that, you need to go back and watch the video, or you need to set up a time with me to meet so I can go over that with you. Okay? So if this makes sense, try the practice problems, check your answers. If it doesn't, you need to see more examples, then please watch the second video. All right, guys, I'm around if you need help. And remember, your assessment is due by Thursday, but I would try to do it before then, because if you don't like your grade and you want to try to get a better grade, I need to assign that to you, and you need to finish it before Thursday, since that's when grades close. So if it's after Thursday and you submit your work and it's not a good grade, I can't extend fourth quarter for you. Okay, so my grades are due on the 15th. So yes, please reach out to me before it's too late. All right, guys, I miss you. I loved getting to see you guys this past week on Friday. It really made me so happy to see you guys. All right, I miss you all, and I will be in touch soon. Bye.